Hello friends, welcome to HP Diamond Academy. In the last lecture we have discussed up to question number 4. So we will discuss question number 5 onwards in this particular lecture. So basically we are discussing the problems on the strings in 2 dimensions. So let's start our discussion. What we have seen in the previous set of lecture is that the intrinsic equation of common catenary intrinsic equation of common catenary is S is equal to C tan psi. And the parametric equations as x is equal to c log sec psi plus tan psi and y is equal to c sec psi. These are the important relations that are required for solving the problems based on strings in 2 dimensions, and the other relations are y square is equal to c square plus s square, and we have the tension at the bottommost point T naught is equal to weight of c length of the string wc. Okay, so this is the weight of c length of the string and w is the weight per unit length, capital W upon length. And we have the tension at any point is proportional to ordinate. Okay, this means tension is equal to weight per unit length times of ordinate. So these are the important relations that are required for solving the problems based on strings in 2 dimensions. So let us solve these questions. Okay, so let us write down these formulas here. Okay, so we have the relations as S is equal to C tan psi, and we have the parametric equations as x is equal to C log sec psi plus tan psi, and we have y is equal to C sec psi, and we have y square is equal to C square plus S square. We have T naught is equal to WC and T is equal to WY. Okay, these are the relations that are required for solving the problems based on the strings in 2 dimension. Okay, so let us solve these questions. Okay, so let us discuss question number 5. What is given in question number 5? So if x bar and y bar be the coordinates of the center of gravity of the arc measured from vertex up to point P, prove that the position of the center of gravity is given by this particular expression. Okay, so how we can solve this? So we have the basic structure of the common catenary is like this. Okay, so this is the basic structure of the common catenary, and we have the axis of the catenary is like this. Okay, and this is our directrix. Okay, so we have the arc is being measured from the point P. This is point P, and we have measured from vertex up to point P. So this is our vertex. So we have the arc from vertex to point P. Okay, so this is our arc. Okay, and we have the coordinates of the center of gravity as x bar and y bar. Okay, and let us take an differential arc as ds. At an arc length of s, we have a differential arc length as ds. Okay, so we have the value of x bar as x bar is equal to x ds upon ds integration, and we have y bar is equal to y ds integration upon ds. Okay, so this we can further write as, so x bar is equal to x ds upon d psi into d psi integration upon ds upon d psi into d psi integration, and we have y bar is equal to y ds upon d psi into d psi upon ds upon d psi into d psi integration. Okay, so this is the value of on further simplification we will get the value of x bar and y bar. So let us further simplify this. Okay, so we have the value of x bar and y bar is given by this particular expression. Okay, so we have the intrinsic equation of the common catenary as S is equal to C tan psi. So from this we have ds upon d psi is equal to C sec square psi. Okay, and we have the value of x as this one and y as this one. So let us place the value. So this is equal to integration. We have the value of x as C log sec psi plus tan psi into 6 psi. This is the value of x into ds upon d psi. ds upon d psi is this one. So C sec square psi into d psi. Okay, upon. And we have ds upon d psi into d psi. So ds upon d psi is this one. So C sec square psi into d psi integration. Okay, so we have the arc like this. This is our arc and this particular point. So we have the integration is from point. Let us take this as point as this is P, this is Q. So integration is from Q to P. Okay, and we have the differential in terms of psi. So at Q we have psi is equal to 0 and at P we have, let us take this as at P we have psi is equal to psi. So this is 0 to psi. So the limit is from 0 to psi. Okay, so the 0 is the value of psi at point Q is 0 because the slope is in the horizontal direction, and at P we have the value of the slope as psi. Okay, so we have the limit is from 0 to psi. Okay, let us further simplify this. On simplification we will get the value as, on simplification of this we will get the value of this as so we have the x bar as x bar is equal to x minus C tan psi upon 2. Okay, so this is the value of x bar. Okay, so just we have to integrate this by parts. Integration by parts. Okay, so now let us find the value of y bar. Similarly, we have the limit is from the value of y bar is 0 to psi. The value of y is equal to C sec psi. C sec psi. C sec psi into ds upon d psi is C sec squared psi into d psi upon integration is from 0 to psi. We have ds upon d psi as C sec square psi. C sec square psi into d psi. Okay. So on simplification we will get the value as y bar is equal to half of C upon cos psi. C upon cos psi plus x cot psi. Okay. This is the value of position of, so the position of center of gravity is given by this particular expression and this particular expression. This is the value of y bar. Okay, so now let us discuss question number 6. Okay, so what is given in question number 6? A rope of length 12 feet is suspended between 2 points at the same level. So we have 2 points at the same level and the length of the rope is 12. Okay, so let us consider this as a rope. Okay, so this is like a common catenary and the 2 points are at the same level. So let us name this as point A and point B. Okay, and the lowest point of the rope is B feet below the point of suspension. So this is our lowest point. Okay, and let us take this as axis of the catenary. Okay, and this is our directrix. Okay, so this is our directrix and the directrix is at a length of C from the lowest point. So this is our lowest point. Okay, the length of the rope is 12. So the length from the point of suspension up to the lowest point is L, and this is also L. Okay, so this whole length is 12 and the lowest point is B feet below the point of suspension. So this is our point of suspension. So the lowest point is at a B feet below the depth of b feet below the point of suspension. Okay, so this is our point of suspension. The lowest point is at a lowest point is b feet below the point of suspension. Okay, so we have to use the formulas here, that is y square is equal to c square plus s square, and we have to use T naught is equal to WC. Okay, so the tension at the lowest point is weight of C length of the string. Okay, so this is the weight of C length of the string, and this is equal to T naught, and we have the y coordinate as y square is equal to c square plus s square. Okay, so now let us use this formula at point A. So at point A we have at point A we have the, so this is let us take the ordinate as ya for the point A. Okay, and ya is equal to b plus c. So this whole length is b from here to here, and this length is c. So this whole length will be ya will be b plus c. Okay, so at point A we have, let us apply this formula. So ya square is equal to c square plus s square. So in this particular case, this is the arc length. So at point A we have, up to point A we have the arc length as this one. So the arc length is L. So S is equal to L for this. So c square plus L square. S is equal to L for point A. Okay, and the value of ya is b plus c. So b plus c whole square is equal to c square plus L square. So we have b square plus 2bc plus c square is equal to c square plus L square. So this get cancelled. So from here we have c is equal to L square minus b square upon 2b. This is the value of c. At the lowest point we have the tension T naught as WC. So this is the value of T naught is the value of the tension at the lowest point, and T naught is equal to weight of C length of the string. So T naught is equal to W times of C. So from here we have T naught is equal to W times of value of C is this one, W times of L square minus B square upon 2B. Okay. So in this particular question we have to find the, show that the horizontal component of tension is given by W times of L square minus B square upon 2B, W being the weight of rope per unit its length. Okay, so we have to apply this particular formula. Okay, that is y square is equal to c square plus s square, and we have applied this formula at point A. So for point A we have the value of s as L, because this is our arc length. Arc length is given as L. Okay, and we have the we have the ordinate at point A is ya. Okay, so this whole length is ya. Ya is equal to this one b plus c. This is equal to b plus c. Okay, so we have placed the value of ya here. So b plus c whole square is equal to c square plus L square. So on further simplification we have the value of c as this one. So we have the horizontal component of the tension is given by T naught, and T naught is equal to weight of C length of the string, that is T naught is equal to WC, and we have the value of C as L square minus B square upon 2B. So let us place the value of C here. So W times of this value of C. So this is the required expression that we have to show in the question. Okay. Now let us discuss question number 7. Okay, so now let us discuss question number 7. A uniform chain of length L is suspended from 2 points A and B. Okay, so these are the 2 points. Okay, and a uniform chain of length L is suspended from 2 points A and B. So this is point A and this is point B. Okay, and these are in the same vertical line. Okay, so that either terminal tension is n times that at the lowest point. So let us consider the tension at the lowest point is T naught. Okay, so let us take the tension at point A as TA and tension at point B as TB. Okay, so by symmetry both the tensions are same. So let us take this as T and this also as T. So we have the tension at the either terminal tension is n times. So TA is equal to TB is equal to T is equal to n times of tension at lowest point. So we have tension is equal to n times of T naught. Okay. So we have the expression as tension at the terminal tension is equal to n times of T naught. Okay. So we have the tension at lowest point. The value of tension at the lowest point is weight of C length of the string. So we have this is equal to, so T naught is equal to W times of C. This is our directrix, and directrix is C length below the lowest point. Okay. So this is equal to n times of T naught is equal to WC. N times of WC. Okay. And we have studied that tension at any point is proportional to, tension at any point P is proportional to ordinate at that point. Okay. So the tension at point A is equal to T is proportional to YA. Okay. So this is our YA. This whole distance is YA. Okay. And we have tension at any point is equal to, W times of ordinate. Okay, so tension at any point P is W times the ordinate at that point P. Okay, so at terminal tension, for terminal tension, T is equal to W times of YA. Okay, and from the parametric equation, we have Y is equal to C sec psi. Okay, so we have tension is equal to terminal tension is equal to W times of W times of the value of YA is equal to C sec psi A. Let us place this value of YA. So this is C times of sec psi A. This is the value of tension, terminal tension. So let us place the value here. So we have WC sec psi A is equal to n times of WC. So this gets cancelled. So from here we have sec psi A is equal to n. Okay. And we have tan psi A is equal to sec square psi A minus 1 का under root. So we have tan psi A is equal to n square minus 1. Okay, so we have the value as sec psi A. Sec psi A is equal to n, and tan psi A is equal to n square minus 1 under root. Okay, and let us use this particular expression. Okay, at the terminal point we have YA is equal to C sec psi A. Okay, so this we have already used. Let us use this particular expression. Okay, so we have S is equal to C tan psi. Okay, so at point A, the value of S is, the whole length is L, so this is L by 2 and this is L by 2. So the distance from, the arc length from lowest point up to terminal point is L by 2. So at point A we have the value of S will be, this is the value of S. So L by 2 is equal to C times of tan psi A. So this is the value of psi A. So L by 2 is equal to C times of n square minus 1 under root. So from here C is equal to L upon 2 times of n square minus 1. This is the value of C. Okay. So what we have to find? Show that the span AB must be. So we have to find the span AB. So span AB. Let us take this distance as XA and this distance also as XA. This distance, let us take this as XB. So since it is symmetrical, the whole length is XA plus XB. Whole length span is equal to. So since it is symmetrical, so both are equal. So this we can write as 2 times of XA. Let us find the value of XA. So XA is equal to, so we have the x coordinate as this one. So x is equal to C log sec psi plus tan psi. Okay, so for point A we have xa is equal to c times of log sec psi a plus tan psi a. Okay, so let us place the value here. So xa is equal to, the value of c is this one, so L upon 2 root under n square minus 1 log sec psi. The value of sec psi is n, so n plus value of tan psi is n square minus 1 under root n square minus 1. Okay, so this is the value of xa. So the span length will be 2 times of xa. So the span length, the span is equal to 2 times of xa. The 2 times of xa will be L upon n square minus 1 under root log of n plus root under n square minus 1. So this is the value of span. Okay, so the span length is equal to L upon n square minus 1 log of n plus root under n square minus 1. Okay, so let us recall this. Okay, so what is given in question? A uniform chain of length L is suspended from 2 points A and B, okay, in the same vertical line. Show that the either terminal tension, so either of terminal tension is n times of, this is equal to n times of T naught, that is tension at the lowest point. Okay, show that the span AB, so this span we have to find. So half of the span is this one xa, so the whole span will be 2 times of xa. So we have used the formula, this one, x is equal to c log sec psi plus tan psi. Okay, and we have to show that the span AB is equal to this particular expression. Okay, so we have discussed up to question number 7. So we will discuss further questions in next particular lecture. Thank you.